So greetings everyone. On behalf of Board 3000, I will be introducing our project MedHive. So in the field of medical science, it is often seen that there are several problems with it. Maybe the data set is really biased towards a certain population, or maybe it hasn't been trained over a good number of data sets. And especially in other countries, we have privacy protection laws like HIPAA and the GDPR. To prevent all of this, we need some kind of a solution that can take the raw data from the patients themselves or from the hospitals, the research institutes in such a way that it doesn't affect the privacy policy. Second, any machine learning model or data science work that is done on them remains unbiased towards the population. And third, all of this should be done in a real-time and fast-paced environment so that the different institutions and the bodies relying on them can work on them. So, to tackle all of these problems, we have developed a solution called MedHive. MedHive is basically a federated learning system which collects data from different sources, and it doesn't even train on our own servers, but rather the data is distributed to multiple contributors, or so-called the way we have described them in our project. The contributors get to be a part of our chain, and they train the model in their systems, and on the after training the data set, the model gets uploaded to a centralized server from which the different hospitals, the research bodies, even generalized user can use on them. So enough yapping about the MedHive project and the theoretical aspect of it. Instead, allow me to describe it from a technical standpoint of view. So as we can see here, this is the high-level data flow diagram of MedHive. So over here, first any user enters some whenever access the MedHive project, they get to see visit a login page, and after that they get to have to register themselves. So they can register themselves as an admin, a data provider, contributor, or a user. So the admin gets the highest level of authority in our application, where they get to choose which kind of models gets to be on the system. All of these are now carried out by AI agents, which is powered by the Grok API. Secondly, we have the data providers, which includes the different research institutes. We have hospitals, we have other pharmaceutical units who are all part of the chain, and they provide are the ones providing the data. Thirdly, we have the contributors. Now, privacy is a really great and important thing, especially when it comes to medical science. So what we have done is, instead of having a centralized server for training the models and everything, the data gets divided into the different users, and there they get to train only on a small portion of the data, and finally the model gets combined. So all of this is done using a federated learning chain, and at every step of the process the data gets highly encrypted, so no one, even us developers, have no clue about where the data is being stored, or how it's being trained, or which user or the contributor is getting to which level of access on the model. Now you must be asking that every time we are talking about the models, there must be some sort of a boundary, because of course we can, it is not really possible to develop a single model or a single AI agent that is capable of handling different types of diseases. And you are absolutely right. That is why we have so-called a hive mind of models, and instead of having a singular models, we have developed this multiple models for different diseases. Like we have an LLM based some DAG application which analyzes symptoms and returns what kind of disease you might be facing. We have an ECG curve analyzer, pneumonia detection from X-ray images, breast cancer detection, glaucoma detection, and many more models are coming down the road. So here's all the different features and the aspects of a and a high level diagram of it, the project. Coming to the next, of course, whenever a project of such a large scale is made, a proper GitHub, proper code base is required to maintain its different versions and keep the code updated to the latest tech stack. So we and our team have developed this repository where all our projects are currently being uploaded, and also has some of the being really kept secure to prevent any kind of external attacks on it. Apart from that, we have used for the front end side of things, tech stack wise, we have used the Next.js framework. For the back end, we are using different frameworks depending on what kind of model we are using, and all of them are deployed using Hugging Face faces. Now, coming back to the backend side of things, say for like we are whenever we are making a model for detection of X-ray images, for that, especially for this X-ray images, we have used a pretty simple CNN-based architecture. Whereas for others, like the in the symptom analysis, we have used proper AI agents and LLM-based analysis. Apart from that, for the breast cancer, we have used simple employees creation because these are working in the highest level and providing the highest level of accuracies. So, say for like here we have one of the servers already up and running over here, and for all of these applications we have used AI agents and Grok. Of course, some of it has been kept blurred to provide secrecy to the service, but you can already see it's the other API calls that have been done here. Apart from that, for the database side of things, we are using Superbase for the main and the core architecture of the project, which takes care of the user side of things, hosting some of the tables for our data, and so much more. As for the other and the LLM side of things, we are using AstraDB. It's a vector database for this project. Okay, now coming covering all the technical aspects, the different tech stacks and everything, one thing still remains. Until and unless we provide a good user experience, a good UI, and a good ultimately put all of them together, the project remains incomplete, which has not been deployed yet. So allow me to introduce the MedHive project live in action. So over here we have the landing page of our project, which has been made really dynamically, and we can, as you can see, that we have the different pages as well. So from the home page we can visit the model hub. Over here you will see the different models that I've described. Let's even take one of the models, say for like the pneumonia x-ray detection, and allow me to upload one image to it. Just a second. Okay, and okay, I have an extra image over here. Open and let's get it analyzed. Perfect, it's a really good extra image and it works just fine. Okay, coming back to the landing page once again. Instead of now, you may be wondering, what if I don't have the sound knowledge of what exact model I should be visiting? Don't worry, MedHive also got that covered. So we can simply ask our Dr. MedLive, our chat assistant over here, and interact with it about the different aspects of the projects as well as what this prototype can actually do. So if I simply ask it, I got an extra image. Okay. Image which model shall I use, and give model, and it brings me to the pneumonia detection model page, and from here I can upload it. Okay, maybe you don't want covering the pneumonia over and over, so it may seems like we haven't deployed the other models, but that isn't really the case. I can go and ask it other questions about that. I have a strong can you take me to the model for sym- symptom analysis? And here it has taken me to our symptoms analysis range, and this model is capable of where we can give our different symptoms and give an expert opinion, and early detection process can also be done. Now all of this is just part of one singular part, which is the model hub part. Apart from that, we have also two other parts that are really critical to this project. One is the admin side of things, and second is the federated learning side of things. So allow me to, instead of being a user, allow me to sign in as one of a contributor first, and then we will be logging in as an admin one. So joining as a data provider, or let me quickly sign in. And over here we have listed as the data upload section, for where as contributors we get to upload the data, which gets it's converts to an encrypted form and gets uploaded depending on our use case, maybe to the AstraDB as a vector database, maybe to the Superbase as a table. And since all of these are carried out by agents and a highly encryption algorithm, even normal users and we as the developers will never be sure where the data gets landed. Apart from that, since you are also providing us data from the business side of things, which I will be covering later, we have the API keys and the API documentation pages. Finally, coming to the most critical part of this project, since all of these are getting from all the training, we are getting hundreds of different models. So we need proper servers as well as proper people who can properly analyze these models and can make sure that the models which are being available to the users are the best possible. For that, we have MLflow systems and the admin side of things. So let's log in as an admin now and check out what extra features they have to handle. So let me quickly log in as an admin. And now if I log in. Okay, so one of the first things that any admin needs is a very good dashboard which through which you can analyze what are the different models that have been trained. Over here, as we can see, the different models that have been trained as of now recently, the different live servers that are running, the global sections from where these models have been trained, and a lot more. Apart from that, they also get access to the different, obviously the different models and anything else. Then we have the different data sets which are currently being uploaded, or maybe there is some kind of pending issues in there that needs to approval. And finally, we have the current data set which have been approved. And if it turns out that the model which has been trained is not up to the mark, the admin can directly discard it, making sure that all the models that are available to the general users is always the best of the best. Now, all of these projects are great and all, but of course, one of the key features we need for maintain such a large scale project is, of course, a proper business model. And for MedHive, we have three proper business plans in action. So first we have the obviously free tier, which is available for all the different users. Of course, in the free tier we have really had to place some restrictions and definitely cannot provide everyone everything for free. Up next we have the pay as you go. This is for the research purpose, the different clinics and the pharmaceutical units who are like providing us the data, providing us a small fraction of cost, and for that they are getting multiple tokens to train their model, maybe check on the different kinds of benefits, the other models that we have, under which we have both a yearly and a monthly plan. And finally we have the enterprise edition. Now the enterprise edition is for the large scale units, say for like Apollo Hospital doesn't want their data to be trained on us, and that's perfectly fine by them. We still are going to are available to provide them proper API keys and federated learning systems on which they can train their data and get their own fine-tuned model. And with all of that, I would finally like to conclude this video covering everything that is and has been developed for MedHive so far. Of course, there are several other key features that are still being developed. There are more models that needs uploading and deployment. And on that note, thank you so much for watching.